The following lecture will cover sections 7.2 to 22.2. This is the second half of our nomenclature unit on naming organic molecules. So the first part of the nomenclature unit was strictly dealing with alkanes and cycloalkanes from sections 4.1 and 4.2. The fundamentals of naming are going to be the same through this second unit, mainly that we identify the parent chain, we identify our substituents, name our substituents, we number our parent chain, and then we put it all together in that original template to build the name of the organic molecule. So we begin with naming alkyl halides or haloalkanes, and we simply treat the halogen atom as if it were a substituent, and we give it a name. Like if you see a fluorine atom attached to a carbon chain, that would be a fluoro group. And we have a chloro, bromo, and iodo groups. The naming is exactly as we did with alkyl substituents. So let's look at a few examples. With our first molecule here, we want to identify the parent chain. So we have our longest chain, 1, 2, 3, 4 carbons. And then we find our alkyl substituents. We have a chlorine and a bromine. We want to number our chain so that our first substituent gets the lowest number. That's why we began numbering on the right side. And now we're going to put the name all together. So it was a form of butane, and we have a 1-chloro group, and we had a 2-bromo. So we put it together, 2-bromo, 1-chloro. The next one, we have several halogens, and we have 1 alkyl substituent. So our longest parent chain with 6 carbons. We have a 1-chloro group, a 4-chloro group. We have a 3-methyl. So when we put it all together, our parent name is hexane. Now we're going to put these in alphabetical order. Remember, chloro comes before methyl, but we do not include this dye alphabetically. Remember, isopropyl was the only exception. So what we're looking at for alphabetizing this is chloro and methyl. And because there's 2 chlorine substituents, we have to tell our reader that we have a chlorine at the 1 position, at the 4 position, and that there's 2 of them, so we say 1, 4, dichloro, and then 3-methylhexane. So pause the video and give these a shot, and when we come back, we'll look at the answers. All right, hopefully you were able to give these a try, and let's look at our answers. Our first molecule, we want to count our longest parent chain. We have 1, 2, 3, 4, 5 carbons, so that's going to be some form of pentane. We have chlorines and bromines attached. Now we have to number our chain. So we want to put our first substituent at the lowest possible number. So that's why we begin numbering over here. 1, 2, 3, 4, 5. And when we build our name, we have 2 bromines, so that's a 4,4-dibromo here. And we're looking at the B versus a 1-chloro. So to build our name, it's a 4,4-dibromo, 1-chloropentane. For our next one, we have a cyclic alkane with a halogen. So that's a 6-membered ring. We have a bromine on there. And now to number this, we're going to go 1, 2, 3, 4, 5, 6. In this case, it did not matter going around clockwise or counterclockwise. If you flip this molecule over like a pancake, it would have been just the opposite there. All right, we've got a 1 bromo, and we have a 1 methyl. So B comes before M. So we say 1 bromo, 1 methyl, cyclohexane because it's a cyclic alkane. Moving on to section 12.1, we're going to look at naming alcohols. Now the rules are very similar to naming the alkanes. However, the parent chain should always include the carbon that has the OH, the hydroxyl or alcohol group, attached. And we want to give the carbon that the OH is attached to the lowest possible number. The OH locant, or the number, is placed either just before the parent name or just before the suffix OL. So there's going to be 2 ways that we can include the number for the OH group. And I'll explain why that is important later. And then cyclic alcohols are numbered at the starting position where the hydroxyl group is. So we're going to give that the number 1 position. All right, let's look at a few examples. With our molecule, our first molecule, our longest carbon chain looks like 1, 2, 3, 4, 5, 6. So we have an OH group, a hydroxyl on the 1 position, and we've got a methyl on the 4. Now we could, now remember, our alcohol is going to be, get an OL suffix. It's not a prefix. There are instances where it becomes a prefix, but we're going to begin understanding this in terms of when you see an OH group, when we name it, we're going to use the suffix OL. So this is some form of hexane. We've got a 4-methyl. But when you see the OH group, that becomes the suffix -ol, and we're going to put that at the end. And we tell our reader where the alcohol is by putting the locant right in front of the parent stem. So go 4-methyl-1-hexanol. Or, this is sort of the way that I prefer to do it. I like to put the locant, or number for the OH group, right before the OL suffix. The reason I like to do this is because when molecules get a little bit more complex and we have multiple suffixes being tagged on, it sort of keeps things more organized for me mentally. However, there are 2 correct ways to do this. Either one is acceptable. We'll show a few more examples here, and then you can give it a try. So our next molecule, we have a 3-carbon chain, 1, 2, 3. We number it. Doesn't matter what side you start from. They're both the same. We have a hydroxyl group on the 2 position. So that would be a 2-ol. You could call this 2-propanol, where you put the locant for the alcohol group before the parent stem, all right, and then the suffix OL. Or you could do your propan-2-ol, putting the locant right before the OL suffix. For our next one, when we have multiple alcohol groups or hydroxyls, our longest parent chain is 4 carbons, 1, 2, 3, 4. Remember, this is not a carbon there. That's just the space and then the OH group. Don't get that mixed up. This is your carbon with it attached. 1, 2, 3, 4. Make sure you see that. It's a common mistake. And that was the same thing here with our first example. So we have an OH group on the 1, 2, and 3 position. So you could call this 1, 2, 3, butane, and then there's 3 OH groups, so that's a triol. You would not say 1, 2, 3 tributanol. That's incorrect. The tri has to go directly with the group that it's specifying. We could also alternatively say butane 1, 2, 3 triol at the end, and this is sort of my preference, but you can use whatever you're comfortable with. All right, next, naming alcohols. We have a couple more examples. We have a 7-carbon chain. We've got a propyl group, and we've got an alcohol. Now remember, we want to give the alcohol the lowest possible substituent, so we're going to give that the 2 positions. So I start numbering from the left, 1, 2, 3, 4, 5, 6, 7. We could call this 3 propyl, and then the 2 that tells us where the alcohol is, 2-heptanol, or you could say 3 propyl, heptan 2-ol. All right, for the next one, we've got a lot of different substituents here. We've got some halogens, we've got an alcohol, and we have an alcohol substituent. So our longest parent chain here can be numbered in 2 ways. You could have, let's see. Nope, there's only one way to do it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we want to start numbering this chain, giving our first substituent the lowest possible number. And then we also have the rule that we want to give the alcohol the lowest possible number, because that's a priority. So, numbering this way, we get our alcohol at the 3 position. So that's going to be a 3-ol. We have, looks like we have a 4,4-dichloro. And we've got a 6-ethyl. All right, so when we're doing this, our dichloro, C comes before E, so we have a 4,4-dichloro, 6-ethyl, and then our 3, because it's a 9-carbon chain, nonene-ol. Now we could have also said 4,4-dichloro, 6-ethyl, nonene-3-ol. So you get the idea. And when we have a cyclic alkanol, the carbon bearing the OH should have the lowest number. All right, so even though a 1, 2, 4, we're going to look at this next example, even though a 1, 2, 4 is lower than a 1, 3, 4. All right, so in this case, we have a cyclic alcohol. We have to give that alcohol the number 1 position. That's the rule. All right. And now because it's a rule, that it is, the rule says it must be number 1, you can exclude the locant 1 from the name, but it is also perfectly correct to put it in. Let's look at how we name this. So we've got a 4-ethyl, a 3-methyl, and a 1-ol. And it's a cyclohexane ring is our parent. So ethyl comes before methyl, so we have our 4-ethyl, 3-methyl, cyclohexanol. You could have done 3-methyl-1-cyclohexanol. You could have done methyl cyclohexane-1-ol. That would also be acceptable. So what you don't want to do is start numbering. So remember, we have our ethyl, methyl, and this is a hydroxyl group. You don't want to number this starting with any of the alcohol or any of the alkyl substituents. You have to start with your alcohol being number 1. So this would not be correct. All right, so pause the video and give this one a shot. When you come back, I'll give you the answer. All right, hopefully you were able to give this one a try. So when we number this, we want to first find our longest carbon chain. We have 1, 2, 3, 4, 5. We're not stopping here because there's one more in the chain, 6. Now, this is a very common mistake because your brain wants to say, oh, there's 2 methyls. But remember, the first rule is we need the longest continuous carbon chain. So we have to include this carbon right in the end as part of our parent chain. Now, when we number this, remember the rule says the alcohol has to get the lowest possible number. The alcohol does not have to be number 1 like it does in a cyclic. And remember, in a alkyl chain, we just have to give the lowest possible number. In a cyclic alkane, it has to be number 1. So because I have to give my alcohol the lowest possible number, we're going to start numbering here. That's 1, that's 2, that's 3, 4, 5, and 6. Now I've got a 2-methyl, 5,5-dibromo, and this is going to be my 2-all. So we put the name together. B comes before M, so it's my 5,5-dibromo, 2-methyl, hexane-2-all. You could have said 5,5-dibromo, 2-methyl, 2-hexanol. That would also have been appropriate. But I prefer to put the locant with the OL at the end, the locant with the suffix. All right, naming alkenes. So very similar to naming alkanes, except we're going to change the ANE suffix to an ENE. So whenever you see a carbon-carbon double bond, you know that your parent stem should end in an ENE. The longest carbon chain should include the pi bond. When you number, the pi bond should receive the lowest possible number. Just for alkenes, we have some other higher priority groups that we're going to talk about later. And then we use a single locant for the double bond, and the locant may precede the parent name or placed immediately before the suffix, just like we did with the alcohols. Okay, so let's look at a few examples. We'll start with something simple. Now we want to name our parent chain. We're going to find our longest parent chain, 1, 2, 3, 4. That's going to be some form of butene. And we give the alkene the lowest possible number, and we're only going to give it one locant in the name. We're not going to say it's a 1,2-butene. It's 1-butene, right? We give the alkene a single locant. That's why it's 1-but for the parent chain and ene because we have a double bond. Or you could also do but-1-ene. This is sort of what I prefer. Keeps things organized. All right, next, longest parent chain, 1, 2, 3, 4. Could you also have started down here? Sure, that could be your 1 position. It's the same. Now, if you're naming this in terms of cis and trans, that could affect it. However, let's not worry about that right now. All right, so we've got a butene. Now the double bond is at a different position. And in this case, we want to start numbering from the left because that puts a methyl group at the 2 position instead of the 3 position if I were to number from the other side. So we have a 2-methyl 2-butene or 2-methyl but-2-ene. This would not be the 3-methyl 2-butene. This would be if you started numbering from the other side. All right, next we have a long carbon chain with 1, 2, 3, 4, 5, 6, 7. Remember, the alkene should be part of the parent chain. That's why I included this one and not this one. The alkene has to be part of the parent chain. And we want to give the alkene the lowest possible number, so I start numbering from the left. My substituents that I'm dealing with here, I have a 2-methyl. And if you remember from the complex substituents, this is a 4-tert butyl. All right, so let's put the name together. For tert butyl, we're looking at the B, not the T. So B comes before M. So it's a 4-tert butyl, 2-methyl, 1-heptene. You could have also said hept-1-ene. Next, we're going to look at cycloalkenes. So when we're naming and numbering our cyclic alkenes, you want to make sure to give the carbon-carbon double bond the 1 and 2 positions. And you're going to number through the double bond. Always, that's key. We number through the double bond. And the substituents groups go on the lowest numbers at the first point of difference. So let's take a look at this cyclohexene molecule. Now, if we start here, 1, then 2, we get our first substituent at the 3 position. Versus if I start here on this carbon and number through the alkene, 1, 2, then that gives me my methyl, my first methyl at 4. So the key here is number through the alkene in the direction that gives you your substituent, your first substituent at the lowest possible number. So we have 2 methyls at the 3 and at the 5 position. So that's going to be a 3,5-dimethyl, and it's a cyclohexene. Now, because the rule states that the carbon-carbon double bond has to be at the 1 position, you don't have to include the locant. However, if you wrote 3,5-dimethyl cyclohex-1-ene, that technically would not be incorrect. Now, moving on to alkeneols and cycloalkeneols. We have to give the alcohol the lowest possible number. Now, I've posted a priority list on the Blackboard page that you can review. And on this priority list, which I'll mention in our Zoom meeting, in our priority list, we see that alcohols take a higher priority than the alkenes. Now, this priority list is all about the suffixes, okay? So the enes, the alls, and then we're going to see with carboxylic acids and aldehydes and ketones and some of our other high priority functional groups. So it may be helpful to pause the video and go find that priority list, and then you'll see that the alcohol has a higher priority over the alkene suffix. With that said, let's look at a few examples. All right, so we want to give the alcohol the lowest possible number. This is some form of cyclohexene. So we're going to give our alcohol the 1 position. And then we want to give our alkene next priority, right, the next highest number. So 1, 2, 3, 4, 5, 6. We've got a 2-methyl, we've got a 2-ene, and we've got a 1-all. Now you could have said 2-methyl-2-cyclohexene-1-all. This 2 is referring to where the ene is. But this is why I like to put all of the locants for the suffixes directly attached to them at the end, because it just, for my brain, it keeps it organized. So sure, we have a 2-methyl, but the 2-ene, see how I put the 2 right in front of the ene and then the 1 right in front of the all? Now, if you said 2-methyl-cyclohex-2-ene all, that would also be correct. The rule states the alcohol has to be number 1, so if you excluded it, technically it wouldn't be incorrect, but including that 1 is just fine. For the next one, remember we want to give our hydroxyl group the lowest possible number. It does not have to be number 1 unless it's cyclic. So we give the lowest possible number, that's a 2. So we have 1, 2, 3, 4, 5 carbons. We've got a 4-methyl. We've got a 3-ene and a 2-all. Methyl, we've got a 3-ene, we've got a 2-all. So let's put the name together. We have 4-methyl, 3-pentene-2-all, or 4-methyl-pent-3-ene, 2-all. And this would be my preferred method. For the next one, remember our cyclic molecules that have an OH group have to have the OH group with the locant number 1 for our hydroxyl. And then we want to give our alkene the next possible lowest number, 1, 2, 3. We number through the alkene. 6. We've got a 6,6-dimethyl, a 3-ene. And we've got a 1-all. And it's a cyclohexene. So we have our 6,6-dimethyl, 3-cyclohexene-1-all, or you could have said 6,6-dimethyl cyclohex-3-ene-1-all. And now for cis-trans alkenes. So we've introduced this before. Cis means that the two identical groups are on the same side of the carbon-carbon double bond, and trans means that the two substantial groups are on opposite sides. So when our chlorines are on the same side, it's a cis 1,2-dichloroethene. If our chlorines are on opposite sides, so we've got hydrogens here. When they're on opposite sides, that's a trans. Because these molecules are not the same. They have different properties. Therefore, they should not have the same name. It's a different spatial arrangement. These are considered stereoisomers. Cis-trans are stereoisomers. And technically, they are diastereomers. But we'll learn more about that in chapter 5. So, same side cis, opposite sides trans. All right, so if we want to name the following molecules, give this one a shot. Pause the video. When you come back, I'll give you the answers. All right, hopefully you were able to give this a shot. With our first one, our longest carbon chain is 6 carbons. 1, 2, 3, 4, 5, 6. We only have an alkene and a chloro group, so we want to give our alkene the lowest possible number, and we want to give the the next substituent the lowest possible number, so that's why I'm going to start numbering from the left. If I started numbering from the right, I would also have a 3-ene. However, my methyl group would have been a 1, 2, 3, 4 versus having my first substituent as a 2-chloro. 3-methyl. And I've got a 3-ene here. So C comes before M, so I have a 2-chloro, 3-methyl, hex-3-ene. For the next one, we have this is a cycloalkenol, meaning we've got an alcohol, it's cyclic, and there's an alkene, double bond. So we have to give our alcohol the number 1 position, and then the alkene should have the next lowest position, so that's 1, 2, 3, 4, 5, 6. That gives us a 5-methyl, a 1-ol, and a 3-ene. So 5-methyl cyclohex-3-ene-1-ol. All right, we learned how to name alkanes, alkenes. Now let's look at alkynes when we have a carbon-carbon triple bond. So the only difference here, we're replacing the ane with the yne to indicate the presence of a carbon-carbon triple bond. Again, the longest chain should include the carbon-carbon triple bond. Again, we want to give the triple bond the lowest possible number. And you want to use a single locant for the triple bond, just like we did with double bonds. We can put the locant before the parent name, or we can put it immediately before the suffix. And again, the OH group does have priority over the carbon-carbon triple bond. So if you look on the priority suffix list, you'll see that the OH group beats the alkene and the alkyne. Let's look at a few examples. A simple one, we want to give our alkyne the lowest possible substituent, or lowest possible number. So the lowest possible number numbering this way gives it a number 2, puts it at the 2 position. So 1, 2, 3, 4, 5, 6, 7. So this would be 2-heptyne or hept-2-ine. For the next one, we've got a bromo group. Let's look at our carbons in the chain. 1, 2, 3, 4. Now the rule states that the alkyne has to be get the lowest possible number. So if we number from the left, our alkyne gets a number 1 position, and the bromo gets the 4. So it's a 4-bromo, 1-butyne, or you could have said 4-bromo, but-1-ine. Now if we have an alcohol, let's count our carbons in the chain. 1, 2, 3, 4, and we have to give the OH group priority. So I have to start numbering to put the alcohol with the lowest possible number. So that's a 1, 2, 3, and 4. That gives us a 3-ine, so 3-butyne-1-ol, or we could have said but-3-ine-1-ol. All right, you can pause the video and give these a shot. When you come back, I'll give you the answers. Right. So let's take a look at our molecules. These are pretty large molecules with a variety of substituents. So let's look for our longest carbon chain. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when we number this, okay, the alkyne takes priority. So we want to start numbering, giving the alkyne the lowest possible number. That's a 3 ine. We've got a 6 isopropyl. Remember, with isopropyls, we use the I in iso alphabetically. We've got a 7 iodo. We've got an 8 methyl, and we've got a 9 bromo. Ooh, that's a lot of substituents. Okay, so B comes first. So we've got our 9 bromo. Next is 7 iodo. Then we have our 6 isopropyl, 8 methyl, and then 3 decine. You could have also done dec-3-ine. It would have been just fine. For our next one, we've got an alcohol and an alkyne. So the alcohol takes priority. So we have to start numbering to give the alcohol the lowest possible number. So 1, 2, so that's a 2 all. 3, 4, 5 ine, 6, 7, 8. So that's a 2 methyl, 5 octine dash 2 dash all. Or you could have said 2 methyl oct dash 5 dash ine dash 2 dash all. We're moving along to naming ethers now in chapter 13. 13.2 deals with the functional group ether, if you remember, the ROR. Now there's two ways that we can name ethers correctly. We can use the common name, and we can use the IUPAC systematic name. Now I'm going to show you both, and if I would ask for this on a quiz or a test, I would ask specifically for the common ether name or the systematic ether name. So that's something to be mindful of. For the common name, we have 3 steps. We want to name each R group. You're naming each of the R groups. We're going to arrange them alphabetically and end with the word ether. So we've got a 2-carbon R group, that's ethyl. We have a 1-carbon R group, that's methyl. We're going to put these together alphabetically with the word ether at the end. Ethyl, methyl, ether. The next one should be familiar. You use this in your the extraction lab. All right. We use tert-butyl methyl ether to extract our naphthalene from, or extract the benzoic acid from the naphthalene in our mixture. So that's a tert-butyl group. We have a methyl group. So B comes before M, so it's a tert-butyl methyl ether. Now the systematic name, we're going to make the larger of the R groups the parent chain, and then the smaller is going to be called an alkoxy substituent. So, for example, let's look at our example here. 1, 2, 3, 4, 5. This is our parent. It's a form of pentane. And then that alkyl group, along with the oxygen, make up an alkoxy. Because it's 2 carbons, it's ethoxy. So we call it ethoxypentane. All right, so if you'd stop the video and give these next two problems a shot, you're going to be looking at the common name and the systematic name for the following ethers. When you come back, I'll give you the answers. All right, so to name the first set using the common name, we've got a methyl. If you recall, this is a phenyl group. A benzyl would have an additional CH2 group in between the oxygen and the aromatic ring. So it's a methyl phenyl ether. We've got a methyl. We've got propyl. So we have methyl propyl ether. Now for our next one, remember with the systematic name, the longest chain is the parent stem. So we have a 1, 2, 3 carbon chain that's longer than the 2 carbon chain here. So this is going to be our parent. We have to number that 1, 2, 3. And my alkoxy substituent, which is the ethoxy group, is at the 2 position. So it's 2 ethoxy, that is telling us where on the chain the ethoxy group is, 2 ethoxy propane. Now for our next one, our longest parent chain is on the left. We have a 3 carbon chain versus our substituent, our alkoxy substituent, that's an ethoxy. Now, because my parent chain is a 3 carbon chain, we want to number it 1, 2, 3, giving the substituent, the first substituent, the lowest possible number, the ethoxy group being the substituent that gets the 1 position. And then we just put it all together with a 2-chloro, 1-ethoxy propane. All right, moving on to section 13.7. You haven't seen this functional group yet, but an epoxide is simply a 3-membered ring that contains an oxygen. It's called an epoxide. They're pretty easy to recognize. You can't miss an epoxide. So we're going to treat the oxygen as a side group, and we're going to give 2 numbers as locants. So let's sort of ignore the, if you ignore this for just a moment and look for the parent chain. We've got 1, 2, 3, 4 carbons in our longest consecutive chain. Now if we treat that oxygen group as a side group or a substituent, so we're going to call this a 2,3 epoxy group, 2-3 epoxy. That's the name of the substituent, the 2,3 epoxy, and then the parent chain was butane. For our next one, let's look for our longest parent chain. We have 1, 2, 3, 4, 5. You could have also done 1, 2, 3, 4, 5 like this, but it would give you an equivalent name, so it's the same. And it looks like our epoxy group, that's going to be a 2, 3 epoxy, 2, 3 epoxy. We've got a 2-methyl on the parent chain, and we've got a 3-ethyl. So we have our 3-ethyl, 2-methyl, 2,3 epoxy pentane. let's look at our next few molecules. You can pause the video and give these a try. When you come back, I'll give you the answers. All right, so let's name the longest parent chain. We have 1, 2, 3, 4 carbons in the chain. If we number it a 1, 2, 3, 4, that gives us a 2, 3 epoxy. And then we've got a 2-methyl. There's a 3-methyl. All right, so we've got our 2,3 dimethyl 2,3 epoxy butane. And whenever you have an epoxide, you want to put the epoxy substituent right preceding the parent stem name. I know you're looking alphabetically, and you're probably wondering why the E does not come before the N. But for epoxides, you want to put the epoxy substituent immediately before the parent chain name. All right, so for our next one, we have a cyclohexane ring, and we can start numbering this either on either carbon here, but we could do 1, 2, 3, 4, 5, 6. So we've got a 1, 2 epoxy. So we name this 1, 2 epoxy cyclohexane. Moving along, we're going to look at section 19.2, which goes over the naming of aldehydes and ketones. So aldehydes, the rules are similar to naming alkanes. We're going to use the suffix, we're going to change the suffix ending in an E to an AL. So that's our suffix for an aldehyde. You choose the parent chain that includes the carbonyl carbon, and you should give the aldehydic carbon, that's your carbonyl carbon, that's your aldehydic carbon, that has to be number 1, despite the presence of other groups. Now, let's look at a simple example. We've got a carbon chain with 4 carbons. It's going to be some form of butane. And instead of butane, we changed the E to an AL, so it's butanal. Moving along, we've got a more complex molecule. Now we've got an aldehyde, we've got an alkene, and we've got an alcohol. So you can only have one high priority suffix if you look at that template. So what we're going to do here is we're going to denote the OH group as a prefix now, because if you look at the priority, the functional group priority list, it's at the end of the notes, and it's also posted on Blackboard. You'll see that an aldehyde beats the alcohol. So when we have 2 high priority suffixes, you have to look at the list to see which one takes priority. So an aldehyde beats the alcohol, so we're going to call this a hydroxy group. And when we number this, the rule says that the aldehyde has to be number 1. So we're going to call it number 1, 2, 3, 4, 5, 6, 7. So that gives us a 7 hydroxy. We've got a 4 ene, a 3 propyl, and 1 al. So when we put this together, 7 hydroxy, 3 propyl, 4 heptene al. You could have said 7 hydroxy, 3 propyl, ket-4-ene al. And because it has to be number one, you don't have to put that one denoting the location of that aldehyde. For ketones, also very similar, our suffix is now -one, O-N-E. When we choose the parent chain, the longest chain should include the carbonyl carbon. And when we number the parent chain, we want to use a locant to identify the position of the ketone. So let's look at a simple example. 4 carbons in our chain. We want to give the ketone, the carbonyl of the ketone the lowest possible number. So 1, 2, 3, 4. So that's 2-butanone. Or you could have said butan-2-one. Now we've got the ketone, we've got an alkene and an alcohol. On our priority suffix list, our functional group priority list, we see that a ketone beats the alcohol. So that means that the alcohol can no longer be the suffix -al. We have to make that a hydroxy. And when we number the chain, we see that we give our ketone here the lowest possible number versus starting here. If we put that as a 1, then we have 1, 2, 3 versus a 1, 2 for our ketone. So we're going to start numbering down in the bottom left here. 1, 2, 3, 4, 5, 6, 7, 8. We've got a 3 propyl. You've got a 1 hydroxy. You've got a 3-ene. And your ketone, there's 2 of them, one at the 2, one at the 6, so that's a 2,6-dione. So putting it all together, 1 hydroxy, 5 propyl, 3 octene, you could have said oct-3-ene as well, 2,6-dione. All right, let's take a look at some molecules here. You can pause the video and try to name these. When you come back, I'll give you the answer. All right, hopefully you were able to give these a try. Let's take a look here. We notice that our first molecule has an aldehyde. And we know that that takes priority over all of the other substituents here. So we want to start, we have to give this the number 1 position. 2, 3, 4, 5, and 6. So we've got a 5,5-dibromo. We've got a 2,2-dimethyl. And that's a 1-al, which you don't have to include that one because the rule says that it has to be number 1. So let's put it together. 5,5-dibromo. The B beats the M, so that's a 2,2-dimethyl. Hexane-al. For the next one, that's a ketone. So we want to give our ketone the lowest possible number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like we have a 6-ethyl, a 4,4-dimethyl, and there's a 3-one. Putting it all together, 6-ethyl, 4,4-dimethyl, 3-nonanone, or you could have said 6 ethyl 4,4 dimethyl nonane -3 -one. It's also perfectly acceptable. Moving along to section 20.2, we're going to look at naming carboxylic acids. All the same rules apply. However, our suffix now becomes oic acid. And the carboxylic acid has the highest priority on our functional group priority list. So, the carboxylic acid should always be included in the longest parent chain. The carboxylic acid should always be number 1. And if it's attached to a ring, we name it as an alkane, whatever it is, carboxylic acid. We'll look at an example below. So let's look at a simple one. We have 4 carbons in our chain. The carboxylic acid has to be number 1. And that's some form of butane, and our suffix is oic acid. So butanoic acid. With our next one, we've got 1, 2, 3, 4, 5 carbon chain. Now here we've got two functional groups that would get suffixes. However, the carboxylic acid beats the alcohol. So that becomes a 5-hydroxy. We've got a 4,4 dimethyl, and that's a 1 oic acid. So you don't have to include the 1 because the rule says it's always number 1. Putting it together, you have a 5-hydroxy, 4,4 dimethyl, because it's 5 carbons in the chain, pentan, and then here's our suffix name, pentanoic acid. Now for this next example, it's just illustrating if it's in a ring. We call it a cyclohexane carboxylic acid. So we name it the alkane, cyclohexane, and we write the word carboxylic acid. Next, we're going to look at some carboxylic acid derivatives, acid halides or acyl halides, anhydrides, esters, and amides. So first, let's look at acid halides. These get the prefix ic acid. If it was a carboxylic acid, the oic acid. Right, so you change the ic acid to a YL. And the halogen gets an IDE. So let's just look, if this were a carboxylic acid, it would be 1, 2, 3, it would be propanoic acid. So we're going to change the ic to YL, and we're going to put the halogen name with an ide. So it's propanoyl bromide. This is your things to remember. For our next one, we have another acid halide, 1, 2, 3, 4 carbons in the chain. 1, 2, 3, 4. We've got a 2-methyl. And if it was a carboxylic acid, it would be 2-methyl butanoic acid. But we're going to change the ic to a YL, add the halogen name with an IDE. So it's 2-methyl butanoyl chloride. Anhydrides, if you recall from our functional group discussion in chapter 2, an anhydride is characterized by the following structural features. You have 2 carbonyls and then that oxygen in the middle. and we're going to change the suffix acid to the word anhydride. So it's 1, 2. This is a symmetrical anhydride. So that's all we're going to be looking at is symmetrical anhydrides. You will not be responsible for asymmetric anhydrides. So we have ethanoic anhydride. See, all we did was change the word acid to anhydride. Acid turns into the word anhydride. For esters, you can think of an ester as being a carboxylic acid combined with an alcohol. Right, so carboxylic acid and an alcohol. So we make esters by condensing the carboxylic acid with the alcohol. So let's call that R prime. So this would be R. Right, so that's how we're going to think about an ester. So esters are named as if the alkyl chain from the alcohol is a substituent. So that's our R prime. We're going to treat that as a substituent. No number is assigned to this alkyl chain, and we name it first by indicating the alkyl group attached to the oxygen, followed by the carboxylic acid. You're going to change the suffix from oic acid to O8. All right, so think of it as an alcohol and a carboxylic acid. All right. We're going to name this alkyl group. That's an ethyl, 2 carbons. So that this would be the alcohol, and then this would be the carboxylic acid. That carboxylic acid is 1, 2. So that would have been ethanoic acid. We're going to change the oic acid to O8, so it's some form of ethanoate, and it's an ethyl. So let's look at a different way of building this name. So let's just look for what would have been the carboxylic acid. That's 1, 2, 3, 4. Would have been butanoic acid. Well, we know it's some form of butanoate because we changed the oic acid to O8. So it's some form of butanoate. Now let's look at the alkyl group. That's a methyl. So we just call that methyl butanoate. For amides, remember these are all carboxylic acid derivatives. We're going to change the oic acid to the word amide. For primary amides, if this had been a carboxylic acid, you would have called this benzoic acid. However, because we have an amide, we're going to change the word oic acid to amide, so it's benzamide. For the next one, we have 1, 2, 3. If that was a carboxylic acid, it would be propanoic acid. Changing the oic acid to the word amide, we get propanamide or propanamide. For the next one, we have 1, 2, 3, 4. That's going to be 1, 2, 3, 4. We have a 2-bromo. If that was a carboxylic acid, it would be 2-bromo-butanoic acid. But because we have the amide, it's 2-bromo-butanamide. For secondary and tertiary amides, meaning that the nitrogen is attached to 2 carbons, or the nitrogen is attached to 3 in a tertiary. So this is considered a secondary amide. This is considered a tertiary amide. We use an N to distinguish what's on the nitrogen. So that N-methyl means there's a methyl on the nitrogen. And if it was a carboxylic acid, it would be 1, 2, 3, 4. Oh, that should be bute, typo, that would be butanamide. So it's an N-methyl butanamide. 1, 2, 3, 4, same typo here, that should be bute. Because we have two methyls, N dimethyl butanamide. All right, so you can pause the video, and you're going to give these next several molecules a shot. We have a carboxylic acid, an anhydride, an acid halide, we have an ester, and we have a primary amide. All right, for carboxylic acid, let's count our longest parent chain, including the carboxylic acid. So we have a 1, 2, 3, 4, 5. We have a 2 propyl group. And the longest parent chain is 5, so that's pent, the carboxylic acid, oic acid. So putting it together, 2 propyl pentanoic acid. This is a symmetric anhydride. All right, so all we're going to do, treat it kind of like a carboxylic acid, 1, 2, 3. That would be propanoic acid, but because it's an anhydride, it's propanoic. Replace the word acid with anhydride. For the next one, this is an acid halide. So 1, 2, 3, 4, 5, 6 carbons in our chain. 4, 5, 6. I've got 5 methyl. And we change the word ic to YL. And the halogen gets an IDE. So we have a 2-methyl hexanoyl chloride. For ester, remember we can look at this first, 1, 2, 3. That if it were carboxylic acid, it would be propanoic acid. So we changed the ic acid to O8, so it's propanoate, and now we just named the alkyl substituent here, so it's an ethyl propanoate. And for our primary amide, right, we're treating it like a carboxylic acid, but just changing the end to amide. So we have 1, 2, 3. That's a 2-methyl. Oh, that should be another typo. Propanamide. The final section deals with the nomenclature of amines. So the IUPAC systematic naming allows 2 different ways to name primary amines. Let's take a look at both of them. So for the first one, we want to name the alkyl group ending in YL, followed by the suffix amine. So the alkyl group, or chain, right, instead of being an ethane, we change it to a YL, so ethylamine. For this one, instead of being like a 2-propane, right, it would just be an isopropylamine. And then here we have cyclohexylamine. This next system is a little bit more complicated, but you can name it as an alkanamine. These are named the same way as alcohols, but the suffix amine is used instead of OL. So we have 1, 2, 3, 4, 5, 6, 7 carbons in the chain. We've got a 4, 6 dimethyl. And we have our amine from the second position. So that's a 2-amine. So it's a 4,6-dimethyl-2-heptane-amine. Or you could have said 4,6-dimethyl-heptane-2-amine. For secondary and tertiary amines, you want to name the alkyl group followed by the amine suffix and use a di or tri if there are more than one of the same group. So, for example, we have 2 ethyl groups on the amine, that's diethylamine. 3 methyl groups, trimethylamine. If you have a methyl, an ethyl, and a propyl, you can just put them in alphabetical order, ethyl, methyl, propylamine. And that's basically, I think these are the simplest ones. So that's basically it for naming amines. So give the next problem a try. You can pause the video, and when you come back, I'll give you the answers. All right, hopefully you were able to give these a shot. So we have a tertiary amine because we have 1, 2, 3 carbons. And these are the easy ones. We have 3 ethyl groups, so it's triethylamine. Now we have a primary amine, so we're gonna name this using the second method that we learned for primary amines, where we put the amine as our suffix. So let's name the carbon chain. We want to go 1, 2, 3, 4, 5. That's some form of pentane. We have a 2-chloro and a 3-amine. So you could have also said 2-chloro pentane dash 3-amine. And if we take a look at our next example, this is where we name the primary amines by changing it, the alkyl group to a YL and then writing the word amine. So that's a butylamine.